So welcome students. इस क्वेश्चन में आपको दिया है un, u with the suffix n is a determinant containing the first column as n square and n cube, and the second column is 1, 2 capital N plus 1 and 3 capital N square, 5, 2 capital N plus 1 and 3 capital N plus 1. So this is an example of a determinant where one column is variable. So first column जो है अगर u1 है तो first column में 1, 1 square 1 cube आएगा. u2 है तो you get 2, 2 square 2 cube. u3 है तो 3, 3 square 3 cube, so on. Only the first column contains n. If you see second column and third column you have capital N's which are constants. So u small n is made up of 3 columns where first column is a variable column, the next 2 columns are constant columns. ऐसा है तो you are being asked to find sigma n is equal to 1 to capital N un. इसका मतलब u1 plus u2 plus u3 plus u4 up to un. So it is a basic question based on the concept that so if only one column is made up of variables, the remaining columns are all constants. Whatever operation you apply on the original determinant can be applied for the variable column. So sigma 1 to n un is same as the same sigma 1 to n आप variable column को apply किया तो आपको काम हो जाएगा. So sigma un n is equal to 1 to n is equal to determinant of sigma 1 to capital N small n, sigma 1 to capital N square, sigma 1 to capital N cube. So whatever operation I apply for un, the same operation you just need to apply it to the variable column, and the remaining columns will remain intact. जो remaining columns है जैसा है वैसे रहेगा. So 5, 2n plus 1, 3n plus 1. This is a very standard concept. ठीक है? This is based on the properties of determinants. So that is equal to. So अब मेरा determinant क्या हो जाएगा? So what is sigma n? n is equal to 1 to n is n into n plus 1 by 2. आपको sequence series में formulas पता है. n into n plus 1 by 2. And the second formula is sigma n square का formula क्या है? n into 2n plus 1 into n plus 1 by 6. n into n plus 1 into 2n plus 1 by 6. And sigma n cube is n square into n plus 1 whole square by 4. Formulas आप sequence series से apply कर लीजिए, and the remaining terms will remain intact. So ये 1, 5 ऐसे रहेगा. 2n plus 1, 2n plus 1 will remain intact. 3n square and 3n plus 1 will remain intact. So जैसा है remaining terms वैसा ही रहेगा. So now what I do is I'll try to take some common terms. अगर कुछ common आ सकता है तो I'll take common. So first column से can I take n into n plus 1 by 2 as common? So first column से मैं n into n plus 1 by 2 common लेता हूँ. So what is left out? The first column 1 will be left out. n into n plus 1 by 2 common लिया तो 2n plus 1 by 3 will be left out. And from the third column n into n plus 1 by 2 will be left out. So these are the three terms which will be left out after I take n into n plus 1 by 2 as common. And the remaining columns are remaining intact. 2n plus 1, 2n plus 1, 3n square and 3n plus 1. This is why. Now what I do is I observe that 2n plus 1 term is there in all the terms of the second row. So second row से मैं 2n plus 1 by 3 common ले लेता हूँ, such that I won't get any fractions. That is equal to n into n plus 1 by 2 already common में है. Extra क्या common ले रहा हूँ? 2n plus 1 by 3 common ले लेता हूँ. 2n plus 1 by 3 common लिया था. बचेगा क्या? 1, 1, 5. So यहाँ 1 बचेगा. 2n plus 1 by 3 common लिया था. यहाँ 3 बचेगा. यहाँ 3 बचेगा. And this will remain intact. So n into n plus 1 by 2, 3n square and 3n plus 1. So now the determinant has been sufficiently simplified. Okay. आप चाहिए तो एक्सपैंड कर सकते हैं और फर्दर सिंप्लीफिकेशन सोच सकते हैं. So what I do is, is there something that I can do to simplify this? So what I do is, this n into n plus 1 into 2n plus 1 by 6 जो है, this is nothing but sigma n square. So this looks like sigma n square, which is there in the options. So इसको sigma n square लिख लेता हूँ. That is equal to sigma n square into. So let me expand this. I don't need to work further. जल्दी जल्दी expand कर लेता हूँ. Into. So let me expand this. Let me write the expansion here. So आपको क्या आएगा? देखिए, sigma n square into. So if you expand this, 1 into 3 into 3n plus 1, that is 9n plus 3 minus 9n square. Say 9n plus 3 minus 9n square minus 1 into, so minus of 3n plus 1, 3n plus 1 minus 3 by 2 times n into n plus 1 plus 5 times 3n square minus of 3 by 2 into n plus 1. So that is the expansion of this term. So that is equal to, so आप देख सकते हैं, are there any cancellations? So first n square terms देखेंगे. So what are the terms that have n square? So minus 9n square. So यहाँ जो है minus of minus plus 3 by 2 n square, and here you have minus 15 by 2 n square. So आप 2 को LCM में भेज दीजिए. So sigma n square by 2 को LCM में भेज रहा हूं. So what happens? यहाँ 18n plus 6 minus 18n square. Here if you take LCM, minus 6n minus 2 minus of minus plus 3n square plus 3n plus 3n square minus of minus plus 3n. इसके बाद यहाँ क्या बचेगा? प्लस 5 is already there. यहाँ 6n square हो जाएगा. 5 6 30n square minus 5 into 3 is 15n square minus 15n square, and minus 3n into 5 is minus 15n. So this is what you get on simplification. So आप कर लीजिए, you can just go with the simplifications. So minus 18n square plus 3n square minus 15n square minus 15n square and plus 30n square are getting cancelled. Similarly, n terms देख लीजिए, 18n minus 15n minus 6n plus 3n are getting cancelled. So effectively getting 6 minus 2 as 4. So sigma n square into 4 by 2, that is equal to 2 times sigma n square is the answer. So option B is the right answer. Thank you.